have to calculate the length of an altitude. So the first thing that we have to do is we have to take a look at these 3 points. So find the length of the altitude r from the triangle with vertices. R is 3, 3, 3, -3, 3, so that's down here. S0 is S0, 6 is somewhere up here. And then we also have T8, -2, which is somewhere down here. The next thing that we have to do is we're just going to quickly draw a triangle for our viewing pleasure. Now, because we're not great at drawing altitudes, what I'll be doing is I'm literally going to sketch something in. And this is the red is my altitude, and Q is the point that makes contact with the altitude and ST. Now, in order to solve this type of problem, on your sheet, I actually put a little section where you could take a moment and write down how to solve this. The first thing that we're going to do is we're going to take a moment and we're going to find the slope of ST. So we need to find this thing, the slope of that. All right? And then what we're going to do is we're going to find the perpendicular of what we found in question number 1. So we find this slope and then we find this. Now, because we found those things, now it will allow us to go and find the equation of ST and RQ. So that's what we're going to do now. That's what we would do as for our third part. Then what we're going to do is, in order to find this Q value, which exists on both on this line and this line, we're going to solve by either using elimination or substitution based on the 2 equations that we found here. And finally, once we've found this point, we're going to go and find the distance for RQ. So just take a moment and write that information down. And now, let's go on to the problem. So the first thing we have to do is we have to find ST, the slope of ST. So let's do that. In order to find the slope of ST, we write MST is equal to this, which gives us this, which means our slope is -1. Now that we have our slope being -1, we're going to have to find the perpendicular in the red here for our equation. So now we're going to find the slope of the perpendicular to ST, and that's just the negative reciprocal. So instead of having -1, we're going to have +1 for our slope along here. And now that we've done that, we have to find our 2 equations. So let's find the equation for ST using the equation y is equal to mx plus b. So if I look at this equation just using graphical analysis, you'll notice that, hey, the y-intercept for this line is 0, 6. So for ST, the slope is -1 and the b value is 6. So that means our equation is -x plus 6. And that's simply because since 0, 6 is the y-intercept, that means b is equal to 6. And that's, we're just using our y equals mx plus b. Now, for our equation that has our slope for our perpendicular, we're going to use the only point that we know between these two, r and q, and that is the r value, the r point, which is -3, 3. So now we start with our equation y is equal to mx plus b, and we substitute. So we're using our slope of 1 and plugging that into our slope in this equation. So now we get this. So now we're going to use our x and y being -3, -3. Plug directly in, and we end up with the following result for b. In this case, our b is equal to 0. And oh my goodness, it doesn't match what we see on my graph. And I did that deliberately because I don't want you guys to think you know what you're doing and just look at the picture that you drew and say, yep, it's right. You need to do the calculations, children. So once we've done that, we've got our b is equal to 0, which means our new equation for our final line for the perpendicular is y is equal to x, using y equals mx plus So after we've completed part 3 of our problem, we have to solve to find the point that ST touches the altitude, and we're going to call that Q. So in this case, I'm going to do, instead of substitution, I'm going to do elimination to remind you how to do that. So I'm going to label equation 1 and equation 2. Equation 1 is y equals x. Equation 2 is y equals negative x plus 6, based on our calculations from before. And what we're going to do is we're literally going to add them together. Now, y plus y gives us 2y. Negative x plus x will give us 0. But now we have 0 plus 6 will gives us 6. And when we solve, we end up with y is equal to 3. Now, once we've got y is equal to 3, we need to substitute y equals 3 into equation 1, which means that our x value is equal to 3. So our solution is 3, 3. So that's the point that Q is. Now, you know that every time we're dealing with calculations that deal with distance, we need 2 points. In this case, we're calculating the distance between R and Q. So let's use those 2 points for R and Q in our distance calculation. So DRQ is given by this, and then we substitute accordingly. All right, and notice how I've changed my brackets into square brackets because I'm using Q as my x2, y2. And when I have a round bracket inside of another round bracket, the outer bracket needs to be turned into a square. So when we finally substitute, we're going to end up with something like this. So simplifying this bracket here, the first bracket, you end up with 6. Simplifying the second bracket, you end up with 6. And we end up with this underneath our square root sign. Simplify again, we end up with the square root of 72, which means that our distance along the altitude RQ is 8.5 units. All right, and there you go. And that's it. Your homework is on the worksheet. Have a good day.